So this is a new derivative for us, the inverse sine or the arc sine of x. We don't know it yet, but we actually know how to get it, right? Because we know how to find the inverse of this, right? If y equals the arc sine of x, then x equals the sine of y. That's the whole point of the arc sine function, right? So this is an equation that we can actually fairly easily find dy dx in, right? We just have to take the derivative of y with respect to x. Remember, we definitely want to, or the derivative of the equation with respect to x. We definitely want to take the derivative with respect to x instead of with respect to y, is because we are after the derivative of this function, right? So we're looking for dy dx. So sine differentiates to cosine. The argument never changes, but don't forget the chain rule. That's the left side. The right side is just 1. So this is pretty easy to solve for dy dx, isn't it? I mean, we just have to do a quick division, and we get dy dx equals 1 over the cosine of y. Or if you prefer, to get rid of the fractions, we can call that the secant of y. All right, but if I say what is the derivative of the arc sine of x, I really don't want to have that answer in terms of y. So that's when we pull out our trig and we say, well, actually, remember that y, being the angle, has a sine value of x. So let's create a triangle whose angle is y and whose sine is x, right? So that means that this side down here we can find pretty easily using the Pythagorean theorem. You take the square root of the hypotenuse squared minus the other leg squared, right? And that does not simplify. Some people like to say, oh, I can take the square root of 1 and I can take the square root of x squared. No. There's a minus sign right there. You guys know better than that. So if I'm going to try to find the secant of y, I've got this nice triangle here that tells me that the secant of y is going to be 1 over the square root of 1 minus x squared. Oh, wait a second. That's what dy dx equals. That's fantastic. Good news. We have derived the derivative. We have figured out what the arc sine differentiates to. The arc sine of x differentiates to 1 over square root of 1 minus x squared. Or if we change x to something more complicated, but in terms of x, then we have to use the chain rule. So we'll multiply that answer by the derivative of our argument. So u prime over the square root of 1 minus u squared. All right, so that's fantastic. Then we can take this new formula out for a spin and see what it can do. For example, if we want to take the arc sine of this value, where u equals x squared, then we just say, okay, well, u prime is 2x. That's the numerator. And then the square root of 1 minus u squared, or x squared squared, or x to the 4th, is our denominator. And that's really all there is to it. That's our derivative. Okay? So what if we decide to change the order of the composition here? This is a composition of x squared and arc sine. This is a composition of squared and arc sine as well. It's just in the other order. So this time I'm going to let u equal the inner function of the arc sine of x, and we're taking the derivative of u squared. So that means we're going to take the power rule, so bring the 2 out front. Our new exponent is going to be 1, but our argument doesn't change. We still have the arc sine of x inside the parentheses. And then we don't forget the chain rule. The chain rule says multiply by the derivative of our argument, and that's just 1 over the square root of 1 minus x squared. All right, so pay attention to the order in which the functions are being composed, right? The order matters, and we get a very different answer depending on whether we square first or arc sine first. All right, so we can do the same thing with arc cosine. So I would strongly encourage you to not watch me do this, but instead do it yourself and then double check your answers. So pause the video, work it out, see what you get. Now that you have an answer for the derivative of the arc cosine of x, let's see if it matches what I get. We're going to invert the equation. We're going to take the derivative with respect to x. We're going to solve for dy dx. And we're going to ask, what does that equal in, oh, I don't know, let's do light blue. In an algebraic expression, right? So remember that, whoops, I'm going too fast, aren't I? Let's slow down here. The argument never changes, but I just changed the argument. Okay, so the angle is y, so make sure we keep that y in the argument. And the cosine of y equals x, so we'll put the x down here this time. So everything is pretty much the same. It just gets flipped around. So that means that we have negative 1 over 1, root 1 minus x squared. Same answer as before, just negative. That's not terribly surprising, I guess. So we end up with, let's not use that light blue, let's use a dark blue for this. Negative 1 over root 1 minus x squared. Or if we use the chain rule, simply put the u prime on the top. And again, this is exactly the same as our arc sine derivative, just with a negative out front. All right, so what happens when we try to take this one out for a spin? See what this one can do. Arc cosine is the outer function. Natural log of the absolute value of x is our inner function, the argument. So we're going to take the derivative of the arc cosine, so that's going to be negative. We've got in the denominator the square root of 1 minus our argument squared. You can do natural log squared of the absolute value of x if you like, or you can put it in parentheses and square it. Parentheses would be very important though, so if you do it that way, make sure you do the parentheses. And then in the numerator, we have to have the derivative of our argument. Well, the derivative of our argument is 1 over x. So actually, 1 over x is how we can write that. Let's make sure that negative doesn't get lost in the mix, so we'll kind of keep that on the outside of the fraction. And that should be it. All right, this one is kind of weird looking. I don't think there's anything reasonable to do here except for the quotient rule, but we'll go ahead and give it a try. Derivative of the numerator, so u prime, is negative 1 over square root of 1 minus x squared times the denominator, so u prime v, minus uv prime. Derivative of the denominator is negative 1. And then divide that all by the denominator squared, divided by v squared. So if we try to simplify this, perhaps we can simplify it a bit. We've got maybe I'll break this up into two fractions. This first fraction has a 1 minus x in the numerator, and it's got two 1 minus x's in the denominator. So one of those can cancel out with one of those, still negative. And then we have the square root of 1 minus x squared, and we also have 1 minus x. Okay, and then double negative here, I'll change that to a positive, and we can put the arc cosine of x in the numerator, and then our denominator doesn't reduce, so it's the original 1 minus x squared that we had here. So yeah, I think that's about all we can do with that.